Okay, so for part A, we need to find all critical points of our function f, which equals 4x e to the 3x. So what we're going to need to do, a critical point, first of all, is whenever f prime of x equals 0 or does not exist. So our derivative equals 0 or does not exist. So we need to find our derivative, f prime of x. So f prime of x now, we can see this is going to become a product rule because we have one function here, which I'll call, in this instance, h of x is equal to 4x, and g of x equal to e to the 3x. So you're probably used to seeing this as f of x and g of x, but since we already have something called f of x, I'm just going to use h of x and g of x. So then h prime is going to equal 4, and g prime is going to equal 3e to the 3x. Because the derivative of e to the 3x, you're just going to write e to the 3x again, and then multiply by the derivative of your exponent, and the derivative of 3x is just 3. So we get 3e to the 3x. So then f prime of x, based on the product rule, should equal h prime of x, g of x, plus h of x, g prime of x. So plugging in now, f prime of x is going to equal 4 times g of x, so e to the 3x, plus h of x, which is 4x, times 3e to the 3x. So simplifying this just a little bit, I can write this as 4e to the 3x plus 12x e to the 3x. Since both of these terms have an e to the 3x in it, I'm going to write this as, I'm going to pull that out, and then that's going to leave me with 4 plus 12x. And what I want to do is I want to set this equal to 0. So since this is a product of things set equal to 0, I can separate this to say that e to the 3x equals 0, and 4 plus 12x equals 0. So let's start with this last one, 4 plus 12x equals 0. I can solve for x, so I'm going to subtract 4. Then I get 12x is equal to negative 4, divide by 12, and that's going to give me that x is equal to negative 1 over 3. So that's a critical point, because that's when f prime equals 0. If I look over here at my other factor, e to the 3x equals 0, well, I can note that if I think about what exponentials look like, their graphs look something like this, where they get close to 0 as the x value goes to negative infinity, but it never actually touches 0. So this actually does not have a solution. So there is no critical point provided by this factor, because there's no solution here. There's no x value I can plug into e to the 3x to get out 0. So that means I only have one critical point. So for part B, I want to find all inflection points of f. So an inflection point is whenever your second derivative equals 0 or does not exist. So for us, that means we're going to want to find our second derivative. So first, let's rewrite our first derivative. So we have f prime of x is equal to e to the 3x times 4 plus 12x. So the thing to note here is that we have something that is once again a product of functions, so we're going to have to use the product rule. So let's jump over here and call h of x 4 plus 12x. So h prime of x is going to equal 12. And let's call g of x, once again, e to the 3x. So similarly, as above, g prime of x will equal 3 e to the 3x. So using the same formula we did above for product rule, we're going to plug stuff in, and we're going to get that f double prime of x, since it's the derivative of this, is going to be h prime of x, because we have h prime of x, g of x plus h of x, g prime of x. So it's going to be 12 times e to the 3x plus h of x, so that'll be 4 plus 12x, times g prime of x, so 3e to the 3x. So similarly, I can note that in this case, we're going to have, both terms are going to have an e to the 3x, so I'm going to pull that out first, or a 3e to the 3x. So I'm going to pull it out. So when I pull out 3e to the 3x, from the first term, I'm going to be left with just a 4, because the e to the 3x will pull out, and 12 pull out 3 leaves you with 4. And when I pull out 3e to the 3x from the second term, I'm left with just the 4 plus 12x. So then I can rewrite this one more time, slightly simpler. 3e to the 3x times 8 plus 12x. So once again, I'm going to set this equal to 0. And note that 3e to the 3x equaling 0, that has, once again, no solutions. And then I have 8 plus 12x equals 0. So then that's going to give me that 12x is equal to negative 8 if I subtract 8 from both sides. Dividing by 12 from both sides is going to give me x equals negative 2 over 3. So my only inflection point is x equals negative 2 over 3. Okay, so for part C, we're told to, from the page before, to determine the absolute maximum and absolute minimum value of f of x on the interval negative 2 to 0. So maximums and minimums can only occur at critical points or the endpoints of our interval. So what I'm going to do is create a table where we have x values and we have f of x values, because we just care about the y value to find the maximum. So what we're going to do is we're going to plug in our endpoints of our interval. So we're going to have negative 2 and 0, and then we're also going to have our critical point, which is negative 1 over 3, which we found in part A. So when we do that, we get plugging those values in for x and then typing into a calculator, we'll get that negative, when x equals negative 2, our y value is negative 0.0198. Negative 1/3, when we plug that in, we'll get negative 0.4905. And plugging in 0, we'll get 0. So the absolute max is the value 0, and it occurs at x equals 0. And the absolute minimum is negative 0.4905, and it occurs at x equals negative 1 over 3. If we need an exact value for our absolute minimum, it's going to be 4 times negative 1/3, which is negative 4/3. E to the 3 times negative 1/3, so that'll be e to the negative 1. And that's going to be the same as our negative 0.4905. So for problem 3, we're asked to evaluate the following limits. So the first thing to do is just to try evaluating the limit. So when we do that, we're going to get here, by plugging in 1, we'll get that 3 times 1 squared plus 4 times 1 minus 7 all over 1 cubed minus 8 1 squared plus 2 times 1 plus 5. And when we do that, we're going to get 0 over 0, which means that this is an indeterminate form, which means we can apply L'Hopital's rule. So I'm going to say apply L dot H for L'Hopital. So that means we're going to take the derivative of the top. So we're going to take now the limit as x goes to 1 of the derivative of the numerator. So the derivative of the numerator is 6x plus 4 over the derivative of the denominator, which is 3x squared minus 16x plus 2. Taking this limit, we're going to get 10 over negative 11. So the limit is 10 over negative 11. So for part B, we're going to do the same thing. We're just going to plug in to begin with. So when we plug in, we're going to get 3 times 1 squared minus 4 times 1 plus 7 over 1 cubed plus 8 1 squared minus 2 times 1 plus 5. And evaluating that, it's going to give us 3 minus 4 plus 7. So that's going to be 6. 1 plus 8 is 9, minus 2 is 7, plus 5 is 12, which then reduces down to 1/2. So the limit is 1/2. So here for part B, we didn't have to apply L'Hopital's rule because we didn't get an indeterminate form when we plugged in 1 to our limit.